Okay, so this is 8.3 on special forms and solving equations. So we're going to learn two special forms today, okay, on helping us factor, all right, quadratics. So the first special form that we have today is let's actually practice that. Let's get that through practicing factoring. So let's factor that out. Okay, x squared plus 6x plus 9. Okay. So remember with factoring, remember that we put the x squared all the way to the front, put the plus 9 all the way to the back, and then we try the x method, correct? We draw the x out. Two numbers that multiply to 9 gets me a sum of 6. What are two numbers that multiply to 9 and gets me a sum of 6? 3 and 3, right? 3 and 3. So this is plus 3x plus 3x. The 6x goes to both the 3x and the 3x. And I'm going to make parentheses around the first two and around the next two, the last two. What's in common between x squared and a plus 3x? An x. So an x comes out. So that's x plus 3 plus 3x and a 9. Same question. What's in common? A 3. So a 3 comes out and it's an x plus 3, right? So then we have two x plus 3's here, so we can gather them up in the parentheses. And what's left over is the x plus 3. Notice that when we did the factoring, we got the same numbers, right? X plus 3 and x plus 3 twice. So what I can do here is I can gather those up. And since it's x plus 3 times x plus 3, I can say x plus 3 quantity squared. Okay? So if I get my first equation, x squared plus 6x plus 9 factors out to be x plus 3 quantity squared, right? This leads me to a special form. It's actually called the perfect squared binomial, but we don't need to know the names of it. We just need to know the form. So here is your special form. Okay. If I say a plus b quantity squared, just like x plus 3 quantity squared, okay? I use a and b just as a generic form, equals x squared, right? It's going to be this first term squared, correct? X plus 3, right? The x is squared. So in the generic form, it's going to be a squared because that a and the x is in the same spot. Okay? The 6x, that is going to be 2ab. 2 times 3 is 6 times x is 6x, right? 2 times 3 times x is 6x, which is that middle term. So it's going to be 2ab, okay? Plus 9, that's just the back number, b squared, okay? And now This back term is always going to be a plus. This middle term will always follow the sign of what's inside. If that's a plus, that's a plus. If this is a minus, this is a minus. Vice versa. Okay? If that's a plus, this is a plus, this is a plus, so this is a plus. If this is a minus, this is a minus. If this is a minus, this is a minus. So whatever this one is, it's going to go right here. Plus. Okay? So along the same lines, we have the second special form, or not A minus, or A plus. It's A minus B quantity squared. The only difference between the plus and the minus here is going to be the sign. So A squared stays the same. The 2AB stays the same. Plus B squared stays the same. But instead of a plus here, I'm going to put a minus because this is a minus. Okay? So it's just going to follow that sign. This symbol is. All right? Okay? My last special form, which we're going to practice today, A squared minus B squared is going to be broken down into A plus B times A minus B. This is called a difference of squares. All right? Okay? So an example of the third one is going to be x squared minus 81. Okay? This, since x squared is a perfect square, is 81 a perfect square? Is 81 a perfect square? Perfect square meaning 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on and so forth. Does 81 fit that mode? Is it something squared equals 81 what? 9 squared, right? 9 squared equals 81, correct? And then x squared equals 81, correct? And there's a minus sign between them, right? So we have this special form. Do we see that? Yeah? So it's just going to be broken down into a plus b times a minus b, which is x plus 9 times x minus 9. All right? Cool with the special forms? Yeah? Yes. Why is it plus m minus? Because if you FOIL it out, that middle term is no longer there. That's the only way that. So if you FOIL this out, right? If we multiply this out, let's try and multiply this out. X times x is x squared. Outside, x times negative 9 is negative 9x. Inside, plus 9 times x is plus 9x. And then the last one is minus 81, right? 9 times negative 9. And the reason why we only have two terms on this special form is that the middle term here will always cancel out, okay? Leaving you with x squared minus 81, okay? That's why that special form kind of exists, because the middle term is always canceled out. Cool? All right. So now we're going to learn how to solve equations. Okay, we learned how to factor. We kind of somewhat were introduced to special forms, right? Now we're going to solve equations. Okay, solving equations I am going to give you the steps. And hopefully by the end of this unit, we're gonna do. Yeah, you guys don't even need to look at the steps. Yeah, you guys are good to go. All right. So your first step here is to make one side equal to 0. Okay, simple enough. All right. Second step is to factor out both sides. But one side is going to equal to 0, so that one side has that equation. Okay. I'm going to go A using check for first the special forms. And then B, X method. And we talked about the X method previously, right? On how to factor. So let's try these two steps with an example, okay, side by side. All right. So let's try something simple. X squared minus 15x equals negative 56. Okay, we're gonna try that out and do that side by side. So your first step is to make one side equal to 0, right? Make one side equal to 0. So what do I have to do to make one side equal to 0? Add 56, right? So we're gonna add 56 here and add 56 here to make that x squared minus 15x plus 56 equal to 0. Okay? And then we're going to factor out both sides. This side is already 0, so there's nothing really to factor. Let's factor x squared minus 15x plus 56. Okay? So x squared 56 plus 56. That middle term is going to be broken down using my x method. Oh, wait. Is there any special form? Are there any special form here? No. Okay. So we're going to use the x method. So multiplies to 56, sum of negative 15. Okay. And if you're still lost on how to do this part of it, list out the factors of 56. Let's do that. Let's list it out. What two numbers equals 56? 9 and 6. Oops. 9 and 6. What else? 7 and 8. What else? 4 and 14. Okay, what else? 2 and 28. 1 and 56. 3? No. 4? We already got 4, 5. No. 6? We already got 6. Huh? 7? We got 8. So that's it, right? Yeah. If you're lost, start here. Okay. Make this list. Okay. And then what we're going to do is with these numbers, we're going to try and get a sum of 15. Okay. Notice that I said positive 15 and not negative 15 because we're not dealing with the negatives and the negatives yet. Okay. So try and get the sum of 15. Let's try 1 plus 56. No, that's just too big. Right? So that's not it. Even 56 minus 1, that's 55. Yeah? I'm going to add and subtract. Okay? 4 plus 14, that's 18. No. 4 minus 14, that doesn't work. Right? That's 10. 28 plus 2, that's 30. 28 minus 2, that's 26. That doesn't work. 8 plus 7. 9 and 6 is not a factor. That's 54. Sorry. Yeah. 8 plus 7, that's 15. Right? 8 plus 7 is, right? So 8 and 7. I know it's going to be 8 and 7, right? Now let's deal with the negative. All right? So I need a positive 56 and I need a negative 15 for my sum. So if it's a sum of a negative number and a product of a positive number, they both have to be negatives, right? Yeah, so it's negative 8 and negative 7. That makes sense? And these are only for the students who struggle with this X method. If you guys can get it right off the bat, then you guys are good. Yeah. Keep doing what you're doing. Okay. So this is a minus 8x minus 7x, right? This negative 15 breaks out to be that. And then we are going to put parentheses around the first two and the last two. What's in common between x squared and negative 8x? And x. So this is x minus 8. Whenever this guy is a negative, you're always pulling it out. So it's a negative 7x and a 56. 7, right? So that's x minus 8. Now, since I pulled out the negative, this positive turns into a negative. Okay? So I have x minus 8 here times x minus 7 equals 0. Right? Don't forget the equal 0 part. Okay, so we factored it out using X method. We're good with that. Now let's talk about my third step. Before I write out the steps, let's talk about it. 8 minus, or x minus 8 times x minus 7 equals 0. Okay? So that means that two products, right, two numbers, when you multiply these two numbers, they equal 0. Correct? Yeah? If x is, let's say, 1, then this would be negative 7, and this would be negative 6. Right? Yeah? So it'd be negative 7 times negative 6. Yeah? So you can see that x minus 8 times x minus 7 is just a product of two numbers. Okay? So think about it. When are two numbers, or when does two numbers have a product of 0? When they're the same, like 2 times 2? Like 4 times 4? Huh? When is the product of two numbers, any two numbers, equal to 0? Give me two numbers that equal to 0. Any two numbers, when you multiply those two numbers, equal to 0. 2 times 0, what else? 4 times 0, what else? 6 times 0, what else? 8 times 0, what else? 9 times 0, what else? Rest are the same. So what's in common between all your answers? Everyone equal to 0, but what else? When is the product of two numbers equal to 0? When is the product equal to 0? He said, I don't want to use names now, record. He said that 2 times 0, 4 times 0, 0 times 6, 0 times 9, and so on. Right? When is the product equal to 0? It's such an easy question that it's something. When there's a 0, right? When one of these numbers equals a 0, the product is a 0, correct? So I have to make sure that one of these numbers has to be 0, right? So my third step is to solve it by making each factor equal to 0. I'm going to make each factor equal to 0. Okay? So which means x minus 8 equals 0, or x minus 7 equals 0. And then just solve for x. I'm going to put the variable because it's not always going to be x. All right? So I'm going to add 8 here. X equals 8. I'm going to add 7 here to make 7. So these two guys are your numbers, 8 and 7. Okay? We got that? Yeah. Just a little extra step between solving and factoring. Yeah? Okay? Let's try another one. 2x squared plus 6x minus 20 equals 0. Okay? So we're going to make one side equal to 0, which it is already. So we're good. Second step is to factor out both sides. This side is 0, so we're good. Using special forms. Is there any special form here? No? Using the x method. So can I pull something out first? What can I pull out? A 2. Thank you. So that's x squared plus 3x minus 10 equals 0. Using the x method here, x squared minus 10. The 3 will be broken down into what? 5 and negative 2. Yeah. You guys see that? Yeah. Two numbers that gets me a product of negative 10 and a sum of 3. 5 and negative 2. Right? 5 times negative 2 is negative 10. 5 minus 2 is 3. Pro tip. Yeah. if you have a positive and a negative number here for your x method, always, always, always put the negative number here in the first slot. Why? Because that back slot is always going to be positive, and you don't have to deal with pulling out a negative. Does that make sense? Yeah, when you pull out a negative, that allows for more mistakes. Okay. So now I'm still using the x method here. So 2 times, what can I pull out of an x squared and a negative 2x? X. So that's x minus 2. What can I pull out of 5x and a 10? A 5. And I have x minus 2 as well, right? Equals 0. So I have 2 times x minus 2 times x plus 5 equals 0. Right? Does this 2 really matter? No. Yeah. So I'm going to solve it by making each factor equal to 0. So x minus 2 equals 0, or x plus 5 equals 0. So here x is equal to 2 and x is equal to negative 5. That's your answers. Because 2 times 0 is still 0. 2 times this 0 is still 0. So that 2 doesn't really matter. Yes? Somewhat, yes, when you're solving. When you're factoring, no. All right? Cool. Questions? No? We're just adding a little step to the factoring portion. Okay? That's the lesson for today, class. That is 8.3 on special forms and solving equations.